Welcome back to Global Education Zone. And in this episode, we are going to be dealing with a topic known as trigonometric ratios of general angles, graphs, and identities. So, basically, when we talk about trigonometric ratios of general angles, graphs, and entities, it's a part of trigonometry that deals with the general angles, and we have different concepts to talk about in that aspect. So, first of all, let's deal with the performance objectives for this video. So, we have some things which we are supposed to cover by the end of this video, and the first of that is basically we are supposed to be able to use the tangent and basically sine cosine ratios in relation to the sides of a right angle triangle. So we should also be able to draw the graphs and also apply certain trigonometric principles and identities. So basically that's the concept of this video today, and let's delve into the basic concept. So basically we have the quadrants and angles. So let's talk about the quadrants and angles. So when we talk about the quadrants and angles, they are basically the fact that these angles they don't exist on their own. They have their quadrants. So each of the angles exists on a particular quadrant on its own. We also have the circle. So this circle, when you divide into four parts, you have the first angle or the first quadrant, you have the second quadrant, the third quadrant, and the last quadrant, which is the fourth quadrant. Now basically you have in this diagram A, you have an angle which is measured from the positive x-axis of the first quadrant. So it's measured from anti-clockwise. So at that angle, you can see it's measured with the arrow. That's figure A. And then in figure B, you can see a negative angle. So in general, positive angles are measured anti-clockwise, where negative angles are measured clockwise. So in these trigonometric ratios, we are going to deal in here. So the thing is, it might look confusing because elsewhere in mathematics, you might have these angles, these ratios measured in a different manner. For example, when we are dealing with bearing, the angles in bearing, they are actually naturally measured clockwise. So there's a video I've done on bearing and distance. You can check it out in the other course my channel. You can check that out. But basically, we are dealing with these concepts here. We don't need talk about bearing and distance. They are quite separate and different. Let's move on to something else. So we have the next concept which we'll be dealing with here, and that is the basic trigonometric ratios. So when we talk about the basic trigonometric ratios, they are basically the properties of these ratios in terms of the right angle triangle. So we have the modern and the traditional definitions. But let's start from traditional definition. In traditional definition, we have them defined in terms of the sine, the cos, and the tan. Sine, cosine, and the tangent. So the sine, cosine, and the tangent, there are three basic trigonometric ratios that are instrumental in the formation of trigonometry, and then they are often defined in terms of the right angle triangle. So which you can see on the screen here, you have the basic trigonometric ratios which can be defined in terms of the side of a right angle triangle, obviously. Then we have the theta, so they are often defined in terms of theta, and you agree with me if you've had some basic knowledge of mathematics that the sine theta is equal to the opposite of hypotenuse. The cos theta is equal to the adjacent of hypotenuse. Then the tan theta is equal to the opposite of adjacent. So those are different things we'll be dealing with in the traditional definition of the trigonometric ratios. And lest I forget, don't forget that the tan theta is equal to the sine theta divided by the cos theta. So the ratio of the sine to cosine is actually equivalent to the tan theta. As you can see that there's quite close relationship between the three trigonometric ratios. So that is basically for the traditional definition of trigonometry. Let's move on to the modern definition. Now in this modern definition, also before we do that, let's talk about the reciprocals. So for these reciprocals, we have that we have the reciprocals of these angles. So for example, you have the secant of angle theta. So if secant is kind of like the reciprocal of cos, so and that is equals to if cos is adjacent of hypotenuse, then secant will be hypotenuse or adjacent. So it's kind of like when you flip the numerator as the denominator and flip the denominator as the numerator. That's what is known as reciprocal or inverse. Then we also have the cosecant, which is the flipping of the sign. So we have the cotangent, which is shortly called cot, which is the inverse or the flipping of the tan. So these are the different reciprocals. You can easily figure out their numerical values by looking for the reciprocals of the sines, cosines, and the tangents ratios respectively. So let's move on to something else, where we're talking about the modern definition of this concept. So the modern definition of this concept, we are going to be dealing with the circle. So in general, we deal with circles here. So when we talk about these circles they are defined in terms of the rotation. So for example, here we have a whole circle, and here, as I mentioned earlier, depending on the sector. So a circle is divided. When we divide a circle into four parts, you have the positive x, negative x, positive y, and negative y. Right now, if in the first quadrant it is bordered by positives only, that is why in the first quadrant you can only get positive values for your sine, cosine, and tangent ratios. But in the second quadrant, it is bordered by a mixture of positive and negative, and every other quadrant apart from the first quadrant is bordered by positive and negative um, values of the x and y um, axis. So that is why it is only in the first quadrant that you can get the positive values only. So, and traditionally, the traditional definition of trigonometry is limited to the first quadrant. So, but we want to talk about it in general details. That's where we have four quadrants. So there are four different case studies where we can four different systems where we can model the values of the quadrants. So we have the first quadrant, which is limited to the traditional. Then we have the three others which together form the modern definition of trigonometry. So that being said, we have similar concepts where we're talking about the ratios. There are some interesting ratios which you need to understand. So the ratios of complementary angles. So let's talk about the ratios of complementary angles. When we talk about the ratios of complementary angles, they are basically the ratios by which these angles they exist. So for example, we have these complementary angles. They are angles that add up to 90, right? So you probably understand that from your basic knowledge of mathematics. Now, first of all, we can deal with theta plus alpha equals to 90, because in a right angle triangle you have your sum of angles equals to 180, and then the sum of other complementary angles equals 90 apart from the right angle itself. So that means your other angles will add up to 90 degrees apart from your right angle. So in this case, in this diagram, you have your triangle PQR. So in this case, our angles P and Q will sum up to 90, and when you add that to the right angle R, it forms of 180, which is the officially and theoretically approved value and sum of the angles in a right angle and indeed any triangle. So basically, we have basically you have the complementary angles here. I'm feeling thirsty. Now, obviously, these complementary angles they have their different behaviors. So that is why if you study them carefully, you will notice that the cos theta is equal to the sine of the complement of theta. So that's just simplest English way to. If I was trying to pronounce that in mathematics, it will involve some kind of jargon. So, and also with sine theta is equal to the cos of the complement of theta, and then tan theta is equal to the cos of the cot of the complement of theta. So that's why cos theta is equal to sine 90 minus theta, sin theta is equal to cos 90 minus theta, tan theta is equal to cot 90 minus theta. So those are different concepts you need to understand. So I guess that does it. So we have that as a summary at the bottom of the screen. You can check it out. You can do a screenshot if you want to have those concepts with you. But we're moving on to some other concepts in this video. So yeah, we'll be going on to discuss the different four quadrants in subsequent detail. So let's start from the first quadrant. So in the first quadrant, you have that all values are positive, obviously, and it is actually the let's call it the harmonious or the analogous model of the traditional under definition of trigonometry. So in this first quadrant, you have the ratio of general angles, which is the first quadrant. You have the OP equals 1. So in this figure, you have triangle OPN, which is a right angle triangle constructed from a unit circle or in a unit circle, anyone. So there you have OP1 equals to 1 unit. So we are making this a unit circle of radius 1. So at the end of the day, we have P1 N1 equals Y. So that is the projection of the y-axis from the on top the as a perpendicular to the x-axis. That's P, and then we also have ON, which is the x-axis itself, which is x. So at the end of the day, we have sin theta 1 equals y, because that is the opposite of hypotenuse, which is y over 1, which is y. Then we also have the cos theta 1 equals x, which is of course equals to the adjacent over the hypotenuse, which is x. Then at the end of the day, we have tan theta, which is opposite over adjacent, that is y over x. So you can see how it forms, and at the end of the day, all of them are positive. So I want you to understand that this is this is the basic definition, and this is the reason, this is the explanation for why you have your sine positive, your cos positive, and your tan positive in the first quadrant. Let's move on to the next quadrant. In the second quadrant, we have they are not so like that in the second quadrant. So in the second quadrant is basically is a mixture of positives and negatives. So, and in the second quadrant, it is basically we first of all start from we have these angles in basically it's a mixture of the first and second quadrant. So basically the continuation of that is kind of like an extension of the first quadrant. So in this case, you have your theta 1, theta 2, and theta 1. So basically there are several definitions. So for example, sine theta 2 is equal to y, cos theta 2 is equal to minus x. So because we have a negative value of x, so that is why. So the only thing that is positive in here is the sign, because sign is equal to the opposite of hypotenuse and it does not have anything to do with the negative x. So that is why you have that. So at the end of the day, in the second quadrant, we have some important conclusions to make. So in the second quadrant, we have so we have this, the first conclusion we have to make in the second quadrant, they are shown in the screen here. So in the second quadrant, we have sine 180 minus theta equals sine theta. That is obviously so. So, and then we also have cos 180 minus theta equals minus cos theta. So as I mentioned earlier, it's only sine that is positive here, the rest are negative. Likewise for tan 180 minus theta equals minus tan theta. So each one is negative. Let's move on to the third quadrant. So in this third quadrant, we have the concept which we have to deal with in the third quadrant, and that is basically the concept of negative values. So in this case, in third quadrant, you have two negative values, just like the second quadrant. So obviously, from what we can see here, you have negative value of both x and y. That is why sine and cos are negative here, and only thing that is positive is tan. Yeah. So and then that was for the third quadrant. So and then when we move to the first quadrant, we will find out that it is only cos that will be positive there. So these are the different quadrants. They have to add. Now you know that these are the different backgrounds. These are the basis for which we have the different reasons why we have our sine, cosine, and tan having different signs. So it's not by magic, it is because of the behavior of these the angles in these quadrants. So that being said, I guess we need to talk about some special angles. So special angles is a concept that is not very difficult to understand, or which might need some explanation. So when we talk about special angles, it might look difficult at first, but special angles, they are just angles that they follow some special properties. So first of all, let's deal with yes, there are special angles. So we have the first special angles which we'll be dealing with here today is yes, this first special angle we'll be dealing today here is sin theta equals 0. So basically sin theta equals 0, and that is the special angles that we'll be dealing with. We also have cos theta equals 1, tan theta equals 0, sin theta equals sin 90 equals 1, cos 90 equals 0. So actually I meant to say, instead of theta I meant to say 0. So sin 0 is 0, cos 0 1, tan 0 is 0, sin 90 is 1, cos 90 is 0, tan 90 is infinity. Yes, and that is also known as undefined. So I remember the first time I heard of undefined was when I was in secondary school SS1. I was like, wow, such a cool term for a naughty concept in mathematics. So that's for that. I hope you've understood the basic concept of trigonometry, and I guess that is where I'll be stopping in this episode. So we'll be dealing with we're done for this episode, and I hope you understand the concept discussed in this episode. And if so, I hope to see you in the next episode for the next concepts. Thanks for watching.